Now, the next topic is progression. What candidate ought to know? Candidate should be able to determine the nth term of a progression. 2. Compute the sum of AP and GP. 3. Sum to infinity of a given GP. So the nth term can be in diverse form depending on the way the sequence is structured. But that of AP and GP, in our previous lessons, we know that as far as arithmetic progression is concerned, because we are talking about progression, as far as arithmetic progression is concerned, we normally have some terms. We have the first term, we have the common difference, we have the last term or nth term, then we have the sum of AP. So in this situation, the first term of an AP is denoted by A, while the second common difference is denoted by D. The nth term has a formula of A plus n minus 1 D. Then the sum has a formula, it has two formulae, the one involving the last term and the other one. So actually that other one is derived from, the one having the last term is derived from the other one. Since we have our L to be equals to A plus n minus 1 D. So the formula is Sn equals to n over 2 into 2a plus n minus 1 d. And we'll close it. So this is the formula for the sum of an AP. So in this situation, we can derive another one which involves that of the last term from this. So 2a is a plus a into 2a equals a plus a, which is plus n minus 1 d. So what I've written here is just to break this 2a into what? A plus a. The plus a is here, so this one is continued. So if you look at from this point to this point is last time, and that's what you have seen here. So instead of writing a plus this again, I'll just write as L. Then I have sum equals to n over 2 into 2, I said 2 into a plus L. So you can see that now. So that means we have two formulae for the last term, for the sum of AP. We have this one that does not involve the last term, then we have this one that involves the last term. This one can only be used when the last term is known. If the last term is not known, the only one that can be used to determine the sum of AP is this first one. Take note of that. Then that is all. Then if you are to determine if you are given A, so if the first term is A, the second term will definitely be A plus D based on this trend, because first term is, it means T1, because this one can be denoted by Tn equals to A plus n minus 1 D. That's the trend. So if you are saying first term, you are talking about T1, and T, that means your n is 1. That's what it means. So when n is 1, so T, this one becomes T1. A plus, what is my n? 1. 1 minus 1, 0, D. So 1 minus 1 is 0. 0 times D, that becomes T1 equals to what? A. So that is the first term. So if it's the second term, we have n equals to 2. That's the second term. So in that situation, we're going to have Tn, n is 2 now, A plus 2 minus 1, D. So we have T2 will now be A plus 2 minus 1. 1. 1 times D, D. So now our second term will be A plus D. So in that situation, that's how, if you have to determine the third term, that's how you are going to have it. So you have the first term, first, second term, and so on. So the first term is A, the second term is A plus D, the third term is A plus 2D. So if you have to determine the common difference, it is simply by subtracting the first term, subtract the first term from the second term. So what's the first second term? A plus D, and you subtract the first term. So this one can cancel this, and you have our D, which is the common difference. That's the pattern for AP. Then let's talk about GP. GP is also a twin brother of AP. So in this situation, our first term remains the same. First term of a GP is also A. Why? Instead of common difference, we use common ratio. We use common ratio, that's R. Then we have our last term. Last term or nth term. Or nth term, which is usually denoted by UN, is now A R raised by n minus 1. That's the formula for the nth term. Then it also has sum of GP. So now the sum of GP, we're having two sums. The first one is, there are two formulae for sum. The first formula is given when R is greater than 1. So in that situation, Sn will be equals to A into R raised by n minus 1 raised by R minus 1. So that is when R is greater than 1. The second formula is saying that Sn equals to A into 1 minus R raised by n over 1 minus R. This one is when R is less than 1. Take note of that. Then the last one is sum to infinity. Sum to infinity. It's a special case here. Sum towards infinity. So sum to the infinity is usually denoted by S, and infinity is what? A over 1 minus R. That's the formula. So I believe in our previous lessons, we ought to have learned all these concepts. So, but the beauty of what we are doing now is to see how we can use this, our understanding, to solve UTLE question within the shortest possible time. Because time is also a factor. It is not all alone to understand the topics, but you must also be able to solve these questions within the shortest time or the time frame. So that is why, and that is our drive here, to solve these questions within the shortest possible time. Now, these are the UTLE questions structured for this topic. So let's see these questions one by one. The question says that find the sum to infinity of this sequence. So I give you a sequence about sum to infinity. So we know that, we know the formula, which is what? S infinity to be equals to A over 1 minus R, where A is the first term and R is the common ratio. So if you look at this sequence, our first term is our A. So our A here will be 9 over 10. Then our common ratio, how do we determine our common ratio? In GP, if you are to determine your common ratio, it is simply by second term divided by first term, which must be equals to the third term divided by the second term. The next one will be what? Fourth term divided by the third term. That is the trend. So here, which one is the second term? This is the first term, this is the second term. So we are saying that 9 over 10 all square divided by first term, which is 9 over 10. So in this situation, we are going to have 9 over 10 times another 9 over 10 divided by 9 over 10. So 9 over 10 can cancel 1 9 over 10, then we have 9 over 10. So this is our common ratio. So in this situation, then we go back to our formula. S infinity will now be first term, which is 9 over 10, divided by 1 minus 9 over 10. So here we have 9 over 10 divided by 1 minus 9 over 10 will definitely be 1 over 10. So in this situation, we are now left with sum to infinity to be 9 over 10 divided by 1 over 10. Then we have sum to infinity to be equals to 9 over 10 times 10 over 1. So this 10 can cancel this 10, you will have 9. So sum to infinity is equals to 9. So we'll go to our option and click on the right option, and that is option B. So the answer to that very first question is option B. That's 9. Then the second question, this one is also testing sum to infinity of the series, but this time around it is the series. You know the difference between series and sequence is that in sequence we have a comma, then in series we have addition. We are adding them up in series. So in this situation we also follow the same principle using this same formula. That's sum equals to A over 1 minus R. So in this situation, what is our A? Our A here is 2 in second question. That's the first term. A is 2. Then the common difference here, common ratio rather, not common difference because we are talking about sum to infinity. Then the common ratio will definitely be R to be equals to second term divided by the first term. That's it. Then our R will now be equals to, what's our second term? That's 3 over 2 divided by 2. So we have 3 over 2 divided by 2 over 1. So we have